Assalamu alaikum. My name is Hamza Masood and my registration number is 16T49. I am a student of UT Texla Telecom Department. Let's start our lecture. In our lecture number 10, we will study FFT, Fast Fourier Transform. It also convert time domain signal into a frequency domain signal. But why we are using FFT instead of DFT? Why we have moved toward FFT? Because DFT take a lot of time, and it also have high computational cost, because it has very high number of multiplication and addition. If we analyze, this is the advantages of DFT. If we analyze in DFT, we perform n into n, means n square multiplication and n into n minus 1 additions. So in FFT we reduce the multiplication complexity, so this is far better than DFT, and it is also less time consuming. Let's suppose we have a signal in time domain x of n is equal to 1 minus 2, this is 0 index value, 1 and again 0. Now in FFT we will introduce the term omega n rk. What is this omega n? We will put omega n equal to e raised power minus 2 pi over capital N. We will put this term equal to this. And now if we get the term rk or nk that we have used in DFT, we will write this term in top of this w. Now see how it works. Now we have get the formula for FFT. Capital X of k is equal to summation n is equal to 0 to capital N minus 1, and W of X of n, W of capital N into n k. Now in FFT we decompose our signal into a simpler signal, and if I decompose this signal into even and odd decomposition, I will get x of k is equal to summation n is equal to 0 to n by 2 minus 1 x of n into omega n k plus summation n is equal to 0 to n by 2 minus 1 x of n w of capital N into nk. Now this part is even and this part is odd. Now for even, put n is equal to 2r, and for odd, put n is equal to 2r plus 1. And if we put this value in this equation, we will get x of k is equal to r is equal to 0 n by 2 minus 1 x of 2r w of n into 2r k plus summation r is equal to 0 to n by 2 minus 1 x of 2r plus 1 and w of n into 2r plus 1 into k. And if we rearrange this term, we will get x of k summation r is equal to 0 n by 2 minus 1 x of 2r k plus w of n into k. We have extra here. If we multiply this k, we will get 2rk plus k, and this k term will independent of this summation, so we will take this term and write before the summation sign. And r is equal to 0 to n by 2 minus 1 x of 2r plus 1. We have 2rk. Now we have the property that w of 4/8 is equal to w of 4/2. Means if this become half, this upper term become half. So we apply this property on this. So this equation, so x of k is equal to summation r is equal to 0 to n by 2 minus 1 x of 2r w of n by 2 rk plus w of nk summation r is equal to 0 n by 2 minus 1 and x of 2r plus 1 w of n by 2 into rk. Now we can write this equation as x of k is equal to, this term we can write e of n or e of r plus nk into O of r. So we have decomposed the Fourier transform in term of er plus n wnk and odd of r. So by using this decomposition technique, we have reduced the multiplication complexity. In DFT, the multiplication was n square, and in now converting into this form, we have formula for multiplication is equal to n by 2 into log n. So what we will get, if we put the value of n here, we will get 8 by 2 into log 8. And we will get, sorry, I have written it wrong. In this case, we have maximum multiplication n, and we have multiplied 2 times, so n into n we have here multiplication, and in this term we have reduced n into n by 2, so our total multiplication become n by 2 into n by 2. If we calculate the multiplication complexity for this case and for this case, we will get the difference. In this, if we put n is equal to 8, we will get multiplication is equal to 64 number of multiplication, and in this case, if we put, we have 8 into 8 by 2, and we get 64 by 2 and divided by 23. So we'll get 23 times multiplication, 32 times, and here we have 64 times. So the multiplication have reduced to half. And if we further subdivide this signal into even and odd, we can reduce more complexity of multiplication. Now in our example, x of n is equal to 1 minus 2, 1 and 0. We have the signal and we have to find FFT, fast Fourier transform. What we will do, we will make these 4 lines, 1, 2, 4, and now after this we'll write this one here and this one here, this 2 minus 2 here and 0 here. Here we have write x of 0 is equal to 1 and x of 2 is equal to 1 and x of 1 is equal to minus 2 and x of 3. Now we will make cross like this. This is the method of FFT, fast Fourier transform, and then join this and skip one line. Join this and this and put here omega of 4 into 0 and omega of 4 into 1, which is this is equal to minus j and this is equal to 1. And now we will take these two terms and on the upper side we will write their sum, which is 2, and on the lower side we will subtract this from upper value. Let's suppose this is 1 and 1 minus 1 we have 0. Again apply this trick on these two. We have minus 2 plus 0 we have minus 2, and minus 2 minus 0 we have again minus 2, and this 2 will come here and this 0 here, and minus 2 we have here 1, so minus 2 into 1 we have minus 2, and minus 2 into minus j we have 2j. Now again apply the same formula. We have here cross like this, 2 minus 2 we will get 0, and again subtract this 2 minus 2 into 4, so minus 2 minus into minus 2 we will get 4, and apply again this formula to this x. We have 0 plus 2j we will get 2j, and by subtracting this we will get 0 minus 2j minus 2j. So this is our x of 0, capital X of 0, this is capital X of 1, this is capital X of 2, and this is capital X of 3. So we have get x of k is equal to 0, 2j, 4 and minus 2j. If we compare this answer with our previous answer that we have solved using DFT, we can see that the formula, that the answer is same, and we get this answer in very less amount of time using this FFT method. Assalamu alaikum. My name is Hamza Masood and my registration number is 16T49. I am a student of UT Texla Telecom Department. Let's start our lecture.